Hi, everyone. Good afternoon from Berlin, where I'm pre-recording this talk. You're probably joining from somewhere else in the world, probably in a different time of the day. And that's the great thing about online conferences. It's very easy to get together to learn about cool things. We're here today to talk about Aerospike Cache TV in apps and how to use it to get the speed of a cache and the resilience of a database. My name is Natalie Pistunovich. I started as a hardware engineer, then I turned into a software engineer, and in one of the startups where I worked, I got to work with Aerospike. That's how I got to know the company. Then I moved to Kenya to become a co-founder of a mobile startup, a beautiful failure. Then moved back to Berlin to become an engineering manager. And then I joined Aerospike to be a lead developer advocate. I love sailing. I love building communities. In the picture in the middle, you see the Go user group. Hi, if anybody from the meetup is watching now. And I'm also very fascinated by everything related to artificial intelligence in space. And I also love plants. If you want to follow me on Twitter, that's my handle. We're here today following this agenda. So we'll start talking about Aerospike. We'll talk about caches. We'll talk about Aerospike Cache TV. What are the benefits of it? What are some use cases? We'll see a demo and some benchmarks. We'll see how can you develop this demo further, and we'll have some time for Q&A. So Aerospike, the database we all know and love. A real-time NoSQL data platform, offers sub-millisecond latencies at a very high throughput. You can scale it up to petabytes. And if you want to see how to scale it more, watch the talk on how to do this with 500 billion entries. It offers strong consistency, very high availability of 5 nines of uptime, dynamic cluster management, a patented flash optimized storage layer, which lowers the costs because it's a great way of doing it. Cache is basically a way to access data fast. You keep your frequently accessed data closer, and this allows you to save time. There are a few architectures in which cache can be implemented. Look-aside caching, or some people call it look-aside cache, or cache-aside, where the application attempts to read data from the cache. If the requested data is not present, so without a cache miss, then the application layer retrieves the data from the DBMS and caches it for the future use. This is the top sketch. Then there is read-through caching, where an application directly reads requests to the cache. And if the requested data is present, it returns immediately. If not, the caching layer is the one that retrieves the data from the backend DBMS and returns it to the application. In write-through caching, as with read-through caching, applications interact only with the caching layer, which synchronously updates the backend DBMS to reflect the write operations at the cost of a higher overall write latencies. In write-behind or write-back caching, similarly to write-through caching, the approach relies on the cache to transparently update the backend DBMS. But the updates are asynchronous, which minimizes the write latencies, but it introduces brief periods when the data in the cache and the backend are not inconsistent, potentially. Then there is write-around caching. And in this approach, it relies on the application layer to write the changed data directly to the backend DBMS. Some designs call for the application to invalidate the cache entry upon successful completion of the write. When this is combined with look-aside cache, the application layer manually refreshes the cache with the DBMS data. When this is combined with a read-through design, the caching layer periodically refreshes itself with the DBMS data. Caching is a very compelling strategy for many applications in different scenarios, but the requirements can be very challenging. Availability, persistence, data consistency, and the operational issues are commonly emerging, especially as the data volumes and the workload increases. Enter Aerospike Cache TV. Aerospike Cache TV allows you to build data-intensive apps or boost the performance of your existing databases by retrieving frequently accessed data rather than making those costly round trips to the backend RDBMS. This is also powered by the hybrid memory architecture of Aerospike, and it's engineered to lower the costs as long as the data volume grows. Give it a try. It's available on our website, aerospike.com/CacheDB. Some of the benefits is that it eliminates the trade-off between speed and persistence. Simply put, a high-performance caching layer must consistently deliver high throughput at extremely low latency, so you can do more with your data and faster. Black Friday, Cyber Monday, your game is going viral? Perfect. Handle the user spikes and the data volumes seamlessly to the user. Some use cases. Queue management. Schedule and queue asynchronous events. You can use this for rate limiting or any other task to control the flow of a traffic to a specific endpoint. Configuration setting. Keep a cached copy of the runtime configurations data, and then you'll have minimal latency in any situation that you need to access this fast. Handling user spikes. In some cases, especially around specific time of the year or just user spikes when you have a specific campaign, caching can prevent the application from being overrun, and it can also help avoid adding additional resources, which translate to costs. Great for use if you have sale on specific items or, as we said, Black Friday/Cyber Monday. API responses. Modern applications communicate via an API. Sometimes a response can be restored in cache for a short duration if you need to be efficient. Unfortunately, it's not very likely that you'll need to respond too many times. 418, I'm a teapot. User authentication. You can deliver this in a very high performance by using the user authentication tokens cached, and the user just gets a faster experience. Content caching. A simple content caching of media or thumbnails to reduce requests to the storage does the benefit that reading frequently accessed data from the cache performance can improve a lot without impacting the architecture. User profiles and web history are often used in shopping carts. For example, Wayfair, the leading online home furnishing retailer, needed a drop-in replacement for Redis with performance of an in-memory cache. They were looking to enhance the customer experience by providing real-time individualized recommendations on more than 14 million products with Aerospike. If you want to read about them more, you can go on the website, aerospike.com/CacheDB, and there's a solutions brief. A leaderboard. It's basically a scoreboard that shows the ranked names and current scores and other data points of leading competitors. Dream11, which is India's largest fantasy sports platform, uses this for their competitions with almost 3 million users playing at the same time with their setup on AWS. Real-time recommendations. PlayStation leverages data to provide intelligent, personalized capabilities to its gamers. Aerospike helps PlayStation capture user data and deliver personalized experience to the gamers. And fast access to the database. Whether it's an RDBMS, MySQL, or something else, relational systems were not designed to operate at the internet scale, and they can easily get overwhelmed by the volume of requests as usage grows. If you put a cache in front of it, you can speed things up. And guess what? That's our demo today. So let's switch into code. So our demo app is a URL shortener. And what it does is that it takes the URL that you give as an input, and then it shortens it into a hash. And if you try to access this hash, it will redirect you to the URL. It is written in Go, and it's relying on Postgres as the external SQL database. And we will see how adding the Aerospike CacheDB will improve the performance. We're implementing this in a look-aside architecture, which means that every time we make a request and the value we want is not in the cache, the application will then go and retrieve the value from the RDBMS. Our code has several parts. It has main.go, which holds the application main part, the frame of it. There are the handlers. There is the storage part, that's the SQL part of it. There is the URL hashing part and the caching part. We will first go over the code, and then we will see how to follow the instructions that are available on the public GitHub repo, which is always available in Aerospike examples. The specific one is called URL shortener. And we will follow the README, so you can then proceed to reproducing this at home and trying to do more cool things. So the first thing that we see when we run the app is this. The main func is always the entry point to any Go program inside the package main. So what we do is start a new app. In our case, this means start the storage. So Postgres, import 5432, and the username, password, the database name. Don't try this at home. Obviously, use better password and so on. And then we have the Aerospike instance, which is our cache. And we have the flag first set to be off, and then we will run this. We'll see how the performance is, and then we will compare this with the cache with the flag on. And we have the new router that we're setting up. And we say that at the root address for this, just serve the file, which is the index. It's a very basic form where you can fill out the URL. And we're announcing that we're listening on port 4000, and we print in quick information whether the cache is enabled or disabled, and then we instruct our router to start listening on port 4000. When something happens, it will jump to one of the handlers, depending on where we go. If we get a hash, we will tell it to execute the code in the redirect handler. If we get an add, we will use the add handler. If we do check, we use the check handler, and remove, we're going to use the remove handler. So the redirect handler basically just redirects the hash into the full URL. It starts by pulling out the value from the parameters. Then it checks whether the cache is on. If yes, it will let us know. It will print this line, and then it will make the redirection. If not, it will try to read it from the storage and will let us know whether it succeeded or not. In case the cache is on and this was not in the storage, it will also add it. And then it will print a different message, which says redirecting to. So in case we got the value from the cache, we will get this notice. If we got the value not from the cache, but from the SQL backend, then we'll get this line printed. Next is the add handler, which is called in case we're adding a value into the storage. So this is when we're adding a new hash. And we parse the URL, we store it, and we announce how successful were we. There is a check to see whether a specific hash already exists in the storage or not. And also it lets us know whether it found it with an HTTP status. And there is the remove handler, which removes a hash from the storage because you don't, this is also removing it from the SQL storage because let's say your business logic is that it's stored for 1 week and then it's being reset. So this is what was happening here. We're also getting an update with an HTTP status, whether this was successful or not. The next part of code is about the SQL database. So we start a new one, and then we define a schema. Yes, yes. And then we have a few functions. One is update. So this is add the new entry into the database. Get is basically read. And you can also get by URL, and we do the remove in case we need to remove one. This code is for the hashing. So we create the hash or we parse the URL from the hash. And the last part is the cache. And let's focus here a little bit. So we use the Aerospike Go client and we call our set cache. We set the timer, the time to live to be 68 seconds. And we create a new instance. If it was all successful, it's just waiting. And then we have the get function. And in this case, it's reading a specific hash, which is the input to the function. And it creates a new key. Then it creates a new bin. Then it does the read with a key and the bin name. And if it was successful, it will print this out for us. And the second function that we have is add. And in this case, we want to add the hash to the connection between the hash and the value, which is the URL. And so let's go ahead and implement this demo locally. We will need 2 Docker images for this. The first one is Aerospike Cache TV demo. And in case you don't have this pre-downloaded, this image, no worries. If you already logged in locally to Docker, you just run this command and it will pull the right label for you, and it will run. So the flag -d says run this image in the background, detached. Name it Aerospike Cache TV. Map the ports 3000 through 3003 to 3000 and 3003 from internal to external, and this is the image that you should be running. So Aerospike Cache TV demo. And the version is following the server one. Next, we will run an image of Postgres, and we will also map the ports to be 4532 to 4532. And in this command, we are naming it Postgres. We are giving it the parameter password as a password. And this is the image that we're using. We're also running this detached. So now we have 2 images running. Perfect. And next we will build inside Postgres a database with the name short URL, because as we saw, this is what is happening here. So we are using a short URL as the name of the database. That's why we are going to Docker execute. So we give the command, go into the container, and with the interactive terminal, run bash, and then go to this path, and this builds a database with the name short URL. Done. Then the last thing for us to do is to run go build. This will create the executable, and the executable name is CacheDB, and then we will run this CacheDB. Perfect. So now we get the message that it's listening on port 4000 with the cache disabled. Let's see what happens if we go to localhost post 4000. We get this beautiful landing page, and we can try to do this URL, and we see that we get this hash 0EA985. So if we try to go there, we will get redirected to this place as we expect. Let's try again. Still works. And from the messages, we see that aerospike.com was added into the cache. That's cool. And then what happens if we press here? We see that the redirection is happening. And great, let's try to redirect to another website. What happens if we go to localhost and we ask to google.com, let's say. So we get this time a different hash. We click on it and look at that, we landed at google.com. And we see this notification now that google.com was added. Cool. Then let's scroll to the part of the benchmarking. So the benchmarking tool that we're using is called WRK, and it basically makes a lot of HTTP requests. My machine is a 2015 MacBook Pro, and I'm not going to use any particular flag. I'm just going to use the default ones, which is 10 seconds and 2 threads and 10 connections. And I'm just going to copy this command. And we see that we get the message running that this is redirecting to aerospike.com. We just go to this URL that we know that is working. And here is the result of the benchmark. So we have made 491 requests per second on average. So in 10 seconds, we made under 5,000 requests. Now, let's see what happens if we activate our cache. For this, we will go here and we'll set this to true. Then we will go build to have a new executable. And then we will run our CacheDB again. So this time we get the message that cache is enabled. And I'm going to go here. And I'm going to go to localhost 4000. I will try aerospike.com again. Now, remember that the image is running. I did not stop the image, the Docker images, so I'm getting the same mapping here. And I'm clicking on this and it works. So I'm going to go here now and I'm going to run the command. The same command, so exactly everything is the same, even same URL, same duration, same number of threads and number of connections. Let's see, this time we get the message that the Aerospike caching is doing the redirection. And let's see what the improvement is going to be. In a few seconds, there it is. So from under 500 requests per second, we got to 1800. Quick math shows that this is more than 3 times improvement, about 3.5 times improvement. And the only thing I did was turn on the cache. Pretty cool. If you go to the README, you will see some numbers from earlier when I ran this. The numbers of requests per second, this depends on what is the load, what is exactly running on my machine at the moment. But you will see that the ratio between with and without log, with and without cache is the same. It's also about 3.5. And the additional benchmarking that you can find in the README is when also turning off the logging just for the fun of it. So this is it for our demo. This can, of course, go to a lot more sophisticated places, and you can use not just a simple URL, you get a string to represent the URL, you can use all the interesting data types. And data modeling in Aerospike is super interesting. This is a whole field on its own. In the Academy, there's a great workshop from last year's summit. You should absolutely watch that on document data modeling. And I will also say that it's from this setup, it's very simple to go also to using the cache with LRU and changing it a little bit to be a proper actual cache. So to see what further steps you can do, you can go to GitHub, and this repo is available for you to clone locally and play with it. You can change the benchmarking tool parameters, and you can even experiment with the rich data types and the different modeling. Scalar data types are, of course, integer, double, string, blobs, bytes. There's collection data types like list and map, a probabilistic data type like hyperlog, geospatial, GeoJSON data type. And you should also look at the document-oriented data modeling. There's also an interesting modeling workshop for IoT in this summit. Make sure you check it out. And if you want to try CacheDB, aerospike.com/CacheDB, you can sign up there and choose between the cloud managed trial or downloading the Docker image and playing with it. So what did we see today? We remembered again what are the benefits of Aerospike that we love. And we talked about cache and the different architectures it can be implemented in. We talked about Aerospike Cache TV. What are the benefits of it? What are some of the use cases? We saw a demo, we saw the benchmarks, and we saw how you can go home and play more with this demo. So I would like to summarize and say thank you very much. Follow Aerospike on Twitter at AerospikeDB. Follow me on Twitter at Natalie Piss, and go to aerospike.com/CacheDB and see what interesting things you can do with CacheDB and how can this help you. Time for Q&A.
Good morning and good evening, everybody. This is George from Aerospike. Natalie, thanks very much for the great presentation. It was very insightful. And now we would like to switch over to the Q&A session. I already see a question. Natalie, please address the question. And I think there are some additional questions coming.
Thank you very much, George. And thanks for everyone who's attending and who's liking the video. So the question is, what is the performance improvement like on the cloud? And the answer is that it depends on your machine normally, but you can expect that the acceleration or the fold, given that you start on the same machine and you add the cache and you're trying this on the same machine, it would be roughly the same increase because you're comparing against the same machine.
Thank you. And I see another one. Another question, I mean.
What if you use more complex data types? And there are plenty of interesting complex data types in Aerospike. Actually, before I'll answer that, I want to give a recommendation to watch the workshop from last year from Ronen Botzer about the data types. And it's 1 hour of very interesting overview of all the options that are out there. Lots of interesting things. And this does become interesting if you put Aerospike in front of a SQL database, because of course, compare a schema versus something that is schemaless can make things interesting. But if you have the setup to have this flexibility, of course, Aerospike will support everything that it supports as a database will be supported also when you use it as a cache.
Thank you. There is another question.
When don't I need a cache? That's always good to know when not to use a tool. Actually, when you know when not to use a tool and you use it only when you do need it, then you can comfortably say that you do understand the purpose of the tool. And you don't need a cache in applications that you don't expect to have a spike of usage. Say you have something that you don't expect to scale, or you don't expect to have a lot of users. This is some sort of like a demo app that you're just building for yourself, and it will not go eventually live or to a wide public, let's say, then you probably will not benefit from having faster access to the data that is repeatedly accessed. And these days, when everybody's online and connected and eventually might end up using your app, it probably makes sense to not use a cache if you are not going in production. If you do go to production, you probably do hope to scale eventually. And then, of course, you do want to have the means to be able to let people, your users, access the data that is repeatedly accessed fast. And if you are in retail, then yeah, you want to do something like Black Friday or some weekend promotion and so on. This is a great use case for cache. If your business model is to never offer any specific sales, that might make sense in some specific case, then maybe it's also a use case where you will not need cache. But I'm a developer, I'm not a business person. I can summarize by saying that if you plan to have scale, you probably want to have cache. And if you're just trying something in a database, maybe you don't need a cache.
Thanks very much, Natalie, for the insightful answer. I do not see any additional questions. So let's wait for a couple of seconds and see if anything else comes up. Again, If you have any questions, please type it in. And
I also want to invite that anybody who wants to ask me questions afterwards, reach out to the platform, or if the conference ends, my email is Natalie@Aerospike, so I'm always happy to chat about Cache. Also about Aerospike, but specifically about CacheDB.
Thank you, Natalie. Since I don't see any new questions, again, I would like to thank Natalie for the great presentation and Q&A session. And I would like to thank all of the attendees for joining us today. And I hope I will see some of you, most of you in the later sessions. Thanks very much, everybody. Bye.
George.